students, welcome back. This is Torres, elbow bump. How are you? Are you doing okay? Is your family okay? Remember, if you need anything, please shoot me an email and I'm happy to help any way that I can. So lucky you get to hear my voice for another lecture. But the best part is we will be reviewing measures of variability. Yay! You've listened to several lectures on measures of variability. Now it's time for you guys to take the test on Blackboard. I want to just quickly review what you're going to find on the test so you know what to expect. Here is the test blueprint. I have linked it in the description box below, along with the Google Slides for this entire chapter for your convenience. The majority of the test will be calculations. So there will be fields inside of Blackboard where you'll actually have to type out a number. Please make sure that you notice if it's asking you to round and to what extent. Like I said, you will have a lot of calculations. So 25 out of the 35 points will be actual calculations. The calculations include still calculating mean, median, and mode, which were measures of center that we discussed last chapter. Calculating 5-number summaries and IQR. There might be a range question in there as well. Calculating variance and standard deviation, z-scores, and theoretical raw scores. And for these, you need to remember that you should be using the sample formula for all of these. Also, in calculations, you'll be reading statistical output in order to perform some of these calculations. So instead of me giving you the scenario, you're going to actually draw it from the statistical output. Finally, you'll be describing distributions and assessing normality, looking at box whisker plots. For those, you'll have 4 matching items and 6 multiple choice questions. If you scroll down on the blueprint, you will notice that you will find some sample formulas that will help with your calculations, or they should help with your calculations. These are all sample formulas. I told you that unless you're told otherwise, you should always assume that we're working with sample formulas from this class. So these are all the sample formulas that you will need for any calculations. These are all including new formulas, not the ones from the previous chapter. A good idea is to snap a picture of this so that if you need this while you're taking a test, you can look it up very easily on your phone or jot them down or something, but just make sure that you've jotted them down correctly. Just by looking at the data, you can tell that this is 10 grocery store visits because we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've got 10 values here and they all describe minutes of wait time in the grocery store checkout line. Okay, and I want to create a 5-number summary with these. So the question is, create a 5-number summary. Calculate the range. Calculate the IQR. Okay, so first thing I need to do is I need to put this in order. So I'm going to see if I can put this in order over here. I believe that the lowest number is 6. Let's scratch that one out. Then I think I see 7. Then 9 is here twice. 9, 9. Then 10 and 12. Then I see 14, 17, 18, 19. Okay, I'm going to scooch this over a little bit here. 17, 18, 19. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. 17, 18, and 19. All good. Oops. All good. Okay. So now I can figure out my 5-number summary. So I've got my min, my lower quartile, also known as Q1 or quartile 1. I have my median. I have my upper quartile, also known as Q3 or quartile 3. And I have my max. Well, the min is 6. My max is 19. And the median is going to be the number that's exactly in the center. So it's going to be the place where there's 5 numbers that are less than that number and 5 numbers that are more. So 1, 2, 3, 4, 5. Okay, here is the balancing point, and I need to think what number is exactly in between 10 and 12, and that number is 11. Okay, so now I've got this half of the data. The number that is exactly in the center of this half of the data is 9. I should put equal signs here. And the number that is exactly on this half of the data is 17. So here's my 5-number summary. For my range, I'm going to take my maximum minus my minimum. So that's going to be 19 minus 6, and that is going to be 13. That's my range. Let me scooch this up a little bit more. Okay. The next question is, what is the IQR? The IQR is the upper quartile minus the lower quartile. My upper quartile is 17 and my lower quartile is 9, so that means that my IQR is 8. So there it is. Now this was when I had 10 numbers to go on. Let's see what would happen if I would have had 11 numbers. Okay, here I have 11 numbers. Let me just count this up to verify. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Great. My sample size is 11. The data is still the same. Number of minutes that I waited at the grocery store checkout line. And the only difference here is that I have an additional 19. So I can actually take the ordered set that I have here and just add a 19 over again at the end. So I'm going to go ahead and do that. 6, 7, 9, 9, 10, 12, 14, 17, 18, 19, 19. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, great. Now I'm going to do the same thing. Scooch this up a little bit. Scooch, scooch, scooch. Okay, I'm going to find my 5-number summary. I've got my min, my lower quartile, my median, my upper quartile, and my max. My min is 6, my max is 19. So let's see what my median is this time. Now I have 11 numbers. So the number that's exactly in the center is going to be the 6th one, right? So 1, 2, 3, 4, 5, 6. The number 12. There's 1, 2, 3, 4, 5 numbers to the left of it, and there's 1, 2, 3, 4, 5 numbers to the right of it. So the median is 12. Now what number is exactly in between here? 9. It's still there. 1, 2, 3, 18. 18 is exactly in between what's left over. So here's my 5-number summary. Let's do my range. Remember, the range is the max minus the min. So I've got 19 minus 6. The range is still 13. Okay. For the IQR, I've got the upper quartile minus the lower quartile. That is 18 minus 9. And now my interquartile range is 9. Okay. So while the range didn't change, the interquartile range did change. It has more variability. Okay, let's do a quick review on standard deviation. So I have some data here, and I have 6 pieces of data. Looks like my sample size is 6. Let's just say these are numbers of flights walked in 6 consecutive days by your neighbor. I don't know, something random. Okay, So we want to find the sum of squares, the variance, and the standard deviation for this set of data. And we want to make sure that we use the sample formulas. Because remember, I said that in my class, I want you to focus on the sample formulas. So let's start off by filling out this standard deviation table. And I'm going to go ahead and start off with all my pieces of data, which are the x's. So this is 5, 5, 10, 20, 5, and 15. Awesome. Now I need the mean. I need the average. So I'm going to need to add up all these numbers together. And I'm just going to kind of make my Google calculator a little bit smaller so that it fits. And I want 5 plus 5 plus 10 plus 20 plus 5 plus 15 equals, and I want to divide that by my sample size, which is 6, and I get my mean is 10. Okay. So this is the mean for all the numbers added up and divided by the quantity of numbers. Okay. Now I'm going to take the deviations from the mean. So I'm going to take my data and subtract the mean. Okay, so 5 minus 10 is negative 5. 5 minus 10 is negative 5. 10 minus 10 is 0. 20 minus 10 is positive 10. 5 minus 10 is negative 5, and 15 minus 10 is 5. Okay, so these are my deviations from the mean. Now I'm going to square these deviations from the mean. So negative 5 multiplied by negative 5 is positive 25. Negative 5 times negative 5 is positive 25. 0 times 0 is 0. 10 times 10 is 100. Negative 5 times negative 5 is positive 25, and 5 times 5 is positive 25. These are my squared deviations. So here I had my data, right? I subtracted my mean from each. I got the distances that each one of my data was from the mean, right? Some were less than the mean, some were right at the mean, some were a little bit more than the mean. Some of them were, this one was less than the mean, and this was just a tiny little bit more than mean, okay? Then I squared them all because I needed these to be positive so that I could add them up, okay? But now what happened is that the unit changed. These were just simple linear units. Now I'm working with squares. So I need to sum my squares to find the sum of squares. So I'm going to scooch this up just a little bit. And I'm going to add up all of these to get my sum of squares. Okay, added all these up to get my sum of squares. So let's bring my calculator over, and we're going to say clear, clear, clear. I'm going to just scooch this over just a little bit over here so I can see the data. Everybody's all happy. Okay, clear, clear, clear. 25 plus 25 plus 0 plus 100 plus 25 plus 25, and I get 200. So my sum of squares, and usually that's abbreviated as SS, was 200. Okay, so that's my sum of squares. That gets me to, I've answered this. I've answered this part right here. Done that. Okay, great. Now I need to calculate the variance. And my variance formula is right here. So what is, this top part is the sum of squares. I took the differences of the mean, right? I took the deviations of the mean, I squared them, and then I added them all up. Now I have to divide the sum of squares by the sample size minus 1. Okay, so my sample size minus 1 is 6 minus 1, and that's 5. So to find the variance, S squared I'm going to take 200 divided by 5. And if I divide 200 by 5, divide 5, I get 40. So my variance is 40. The last thing I have to do, and I'm going to do that one in red. We'll just do Christmas colors today, I guess. Okay, so the last thing I need to do is I need to find my standard deviation. If you compare these two formulas, you'll notice that the only difference is that the standard deviation takes the square root of the variance. So I'm going to go ahead and come back down here, and I'm going to take the square root of the variance, square root of 40. And if I were to put that into the calculator, and we'll just round to hundredths, my standard deviation is 6.32. Okay, so now I have solved for my sum of squares, my variance, and now I've solved for the standard deviation. This last example, I'm going to go ahead and just do a little sample of using statistical output to calculate z-scores. Okay, so this is some gas price data. My count is 10. My mean is 119.9. And my standard deviation, I'm just going to say is 3.6. Okay. So if I wanted to calculate z-scores, I could go ahead and look what I'm getting. Look, can you see what look at this. It's getting, it will, if I get somewhat like a straight line, it straightens it out for me. Isn't that amazing? Oh, it's so satisfying. Okay. All right, so here is my normal curve. Looks good. And I'm going to go ahead and, oh, it's going to do it again. Is it going to straighten out? Oh, okay. This is amazing. All right, I'm going to go ahead and put my z-scores here, and I'm going to go ahead and put my raw scores here. Z-scores are 0, 1, 2, 3, -1, -2, -3. Those never change. And my raw scores are right in here. So that's where I'm going to write them. And, you know, just to make things easier on both of us, this is what I'm going to do. I'm going to round these. Instead of saying this is 119.9, I'm just going to say this is 120. Okay? Because I just want to make things easy on us. And instead of saying that this is 3.6, I'm going to go ahead and round this to 4. Okay, so what is this saying? This is saying that the mean is right here, 120, and this distance is 4. 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 And this distance is 4. So if this is 120, then the raw score equivalent of a z-score of +1 is going to be 4 more than 120. So that's going to be 124. And if I add the standard deviation again to 124, then I would get that the raw score equivalent for a z-score of +2 when the mean is 120 and the standard deviation is 4 is 128. Okay, see how I just basically added the standard deviation. Now, if I asked you what is the theoretical raw score for a z-score equivalent of +3, then you could just add this 4 again and say that the raw score equivalent is 132. On this side, I can say that if the mean is 120 and the standard deviation is 4, then the raw score equivalent for a z-score of -1 would be 116. I subtracted 4 from 120. If we wanted just to do it with the calculator, you could if you feel more comfortable. Next thing I would do is if I wanted to find the raw score equivalent for a z-score of -2, I would just take clear 116 minus 4, and I would get that the raw score equivalent for a z-score of -2 when the mean is 120 and the standard deviation is 4 is 112. Okay, and then if I wanted to go ahead and subtract again to find the raw score equivalent for a z-score of -3 when the mean is 120 and the standard deviation is 4, then I would subtract 4 again and I would get 108. So if the question is, what is the raw score equivalent for a z-score of 2? What is the raw score equivalent for -2 z-score? I can say that it is 112. And this would be cents, 112 cents. I was just talking about gas prices. If I wanted to ask, a gallon of gas cost 124 cents, what is the z-score that corresponds with this price? I would say that the z-score for a gallon So just kind of scooch this up over here. But if my question is, what is the z-score for a gallon that costs 124 cents? Well, here is my 124 cents. So the z-score equivalent is +1. If the question had been, what is the z-score equivalent for a gallon that costs 132 cents, then my z-score equivalent would have been 3. Okay, so once you set this up, you have a very clear understanding of what's happening with the anchor z-scores. So what's the big idea? Today's big idea is that measures of variability describe how the data is different. There's lots of different ways to describe the spread of the data, the variability, its differences. Ideas that describe how the data is different are things like box plots, 5-number summary, interquartile range, standard deviation, variance, and z-scores. Study hard because I know you're going to do great on this test. So that's it for today. With that said, don't forget to check your emails, check Blackboard, do your homework, and subscribe to this channel. Even better, hit that notification bell so you know when there are new videos for this course, okay? This is your teacher, Torres, saying stay safe, and I will be waiting to give you a virtual elbow bump in the next video. Ciao!